So when we've been drawing Lewis structures, we are drawing lines, for example, in the compound H2, between two atoms that represent a bond. What is that bond actually representing? This bond is representing electrons shared between two atoms. That's the definition of a covalent bond that you need to know. A covalent bond is when electrons are shared between two atoms. And we know that this occurs when we have two nonmetals that are bonded together. Well, why is that the case? We've memorized it. Two nonmetals, that's a covalent bond. Well, it all has to do with electronegativity. It all has to do with electronegativity. So what we have here on this periodic table is electronegativity values for all the different elements. And remember, electronegativity here is the ability of an atom to attract electrons to its nucleus. Another way of saying that is how badly an atom wants electrons. So higher electronegativities mean an atom wants electrons more than another element that has a lower electronegativity. Okay? So let's talk about another example. Let's talk about fluorine gas, F2. Okay? Well, fluorine on the periodic table is the most electronegative element. It has an electronegativity value of 4.0. There's no units on the electronegativity scale. It's just a relative scale. Okay, so we're just comparing electronegativities of elements to each other. So if we drew the Lewis structure for F2, there would be one single bond between them with enough lone pairs, 3 lone pairs around each atom, to give us the total number of valence electrons that we need. Well, what is going on here? If we look at the electronegativity values, each of these has an electronegativity value of 4.0. So that means that both of these atoms are going to be pulling. Imagine these electrons are kind of in the middle. They're like in the middle of a tug of war, like the middle of the rope. And both fluorine atoms are going to be pulling on those electrons because of their electronegativities. Well, since both atoms have the same electronegativity, they're going to be pulling on those shared electrons in equal amounts. So we call a bond that is between two atoms with similar electronegativities non-polar covalent bonds. So that's a definition you need to know. Bond between two atoms with identical electronegativities. Okay. Well, where's this word polar coming from? What does that actually mean? Well, if we move this up, okay. Let's talk about another example. Let's talk about sodium fluoride, NaF. You could draw a Lewis structure for, NaF, okay, showing them bonded together like so, okay. And what we see now, if we look at the electronegativities for these two elements, is that fluorine has an electronegativity of 4.0, and sodium has an electronegativity of 0.9. So what this is telling us is that fluorine, if these electrons are getting tugged on by both elements, fluorine is going to pull on those electrons way more than the atom of sodium will. We know that essentially it's going to pull on it so much that that electron is only going to be found on fluorine. And so we learned that electrons get transferred between metals and nonmetals, and we called this an ionic bond. Okay? Well, what if we have a bond that's kind of in between? Well, let's talk about CH4, methane gas. The Lewis structure for CH4 looks like this. Okay. And if we look at let's analyze like one of these bonds over here between the carbon and this hydrogen. Well, the electronegativity value of hydrogen is 2.1, and the electronegativity value of carbon is 2.5. So what this is showing us is that these electrons in this bond are getting pulled on by both atoms, but they're getting pulled on a little bit more by the carbon than they are by the hydrogen. So this bond is not a non-polar covalent. because the electronegativity values are not identical. It's not an ionic bond because the difference is not very large. Like over here between sodium and fluoride, it was 3.1. Here it's just a 0.4 difference. Okay. So we call this a polar covalent bond. Okay. Polar, when we say polar, a polar bond, or if we're talking about polarity, is an uneven distribution of electrical charge. So that's the definition you need to know for polar and polarity. So, because in this bond, what we have is an uneven distribution. The carbon has more of the electronic charge on it than the hydrogen does. Whereas up in this molecule, the fluorine has more of the electronic charge on it than the sodium does. Okay. So how can we represent this? How can we represent this? Well, if we take a compound like HF, hydrofluoric acid, okay, we drew the Lewis structure for HF, all right? We now know that according to electronegativities, well, if we find fluorine, the electronegativity is 4. For hydrogen, it's 2.1. So hydrogen, I'm just going to kind of label this 2.1, 4.0. That the bonds that are shared between these two nonmetals, the electrons in this bond that are shared, is getting pulled more by the fluorine than by the hydrogen. And since we know electrons have a negative charge, that means that there's more negative charge on the fluorine than there is on the hydrogen. So the way we represent that, since it's not a purely ionic bond, like NaF we know is more ionic, and we represent that by Na+, meaning that sodium lost that electron completely and fluorine gained it completely to make it NF negative. When we have a polar covalent bond, we represent the distribution of charge with a little lowercase delta in the Greek alphabet with a symbol to represent the charge. So I'd put a small little delta plus on the hydrogen and a small little delta a small little delta minus on the fluorine. Because what this is telling me is that some of the charge, not all of it, but the majority of the negative charge is on this fluorine atom. Whereas since those electrons are getting pulled towards the fluorine, that means there's less negative charge on the hydrogen, so that means it's more positive. And we know that it's all because of the electronegativity values. So in general, the higher the electronegativity of an atom, the more negative charge it's going to have on it. And this allows us to predict acidity, it allows us to predict reactivity, it allows us to predict dissociation. It'll give us a lot of different tools as we move forward. Okay. What you have here is an electrostatic potential map for a molecule of HF. Because we know that red regions represent negative charge and blue regions represent more positive charge. So if we were to draw the Lewis structure to match this picture, try to predict it yourself, well, we would have hydrogen down below at the blue area and fluorine up top in the red area, because we know that there's more negative charge on fluorine than there is going to be on hydrogen. So what you need to be able to walk away with from today is the idea of how does electronegativity influence bonding between atoms. You need to know the definition of a non-polar covalent bond from up here. You need to know the definition of a polar covalent bond from right here, and what the word polar or polarity means in general.